Hello, High Point Physical Science. This is going to be the first of 3 videos that I'm going to upload for you this week. So we are basically going to be going over the review questions in the back of Chapter 5. We'll be finishing Chapter 5 this week. We are going to start in the very back with the review questions that have math. We're going to start with math on page 108. So open your books to page 108, and we're going to take a look at some of the questions that have a DS in front of them. Question number 1 says, an elevator rises at a constant speed of 2 meters per second. Is the elevator accelerating? So what do you think? It says it's moving at a constant speed. So that's a clue that it is not accelerating, okay? Because accelerating means change in speed. So it is not. Okay, it is not accelerating because it is at a constant speed. All right. The next question says, what can you say about the net force acting on the elevator? Well, we know from Newton's first law that every force has an opposite but equal force, and when those forces are in equilibrium, the force is actually 0. The sum of the forces is 0. There's no net force, so the object is in equilibrium. So we're going to write that. The elevator is in equilibrium since the speed is not changing. All right, and I'm going to quickly prove this to you using Newton's second law. Okay, it says F equals mass times acceleration, and acceleration equals 0 because the speed's not changing. Anything times 0 equals 0. So the force would be 0. 0 times m equals 0. Let's take a look at number 24. Okay, the elevator and passengers have a mass of 5,500. Sorry, let's read that. The elevator and passengers have a mass of 5,500 kilograms. After a stop at the 5th floor, the elevator accelerates upward uniformly at 1 meter per second squared until it's rising at 2 meters per second. What is the magnitude of the net force on the elevator as it accelerates? All right, so the question is, what is the force during that portion of time when the elevator is accelerating? Once it begins rising at 2 meters per second, it's no longer accelerating, and we don't care about that part. It's asking about the force once it's accelerating. So 24, all right, we're going to use a formula, so I'm going to write down the formula first. Always write down the formula you use. F equals ma. So you write that down first. So you should write that on your paper. F equals ma. And then we're going to write what m and a are equal to. M is our mass, and that is equal to 5,500 kilograms. A is our acceleration, and that is equal to 1.0 meters per second squared. Then we're going to do what's called plug and chug. I'm going to take this number here and put it in place of the m. So I'm moving this to the m, right? So if this were m, I'm going to say this were m, right? I'm going to erase m and put 5,500 kilograms, right? And in place of a, say this were a, right? A is equal to 1 meter per second, so I can just replace it with the number. All right, do you see what I just did there? I replaced m with what m is equal to, with the number, and I replaced a with the number that it's equal to. Then I just do the math. 1 times 5,500 equals 5,500. And it's asking for force, so I know my units are newtons. All right, so you want to write everything down. The formula, what mass is equal to, what acceleration is equal to, and substitute the numbers. This is called substitution or plug and chug. F equals, write each number down and write the last number and make sure you write the units of force. All right, and we can even put a little box around our answer. All right, take a look at number 25. Number 25 says, calculate the weight of the elevator. In which direction does the force vector act on the elevator? All right, let's focus on the weight of the elevator. What this question really means is, what is the weight of the elevator and the passengers that it gave you? It gave you the mass, but what is its weight in newtons? That's really what it's asking. So 25, we're going to use a new formula. F, the force of the weight, equals the mass times g for the acceleration of gravity of anything, acceleration due to gravity on the earth. So we wrote out our formula. Force of the weight equals mg. Let's write out what it's telling us. The mass of the elevator and passengers all together, 5,500 kilograms. The acceleration of any object on the earth due to gravity is 9.8 meters per second squared. So let's go and substitute everything in our formula. Force of weight, rewrite the number for the mass. Okay, for G, rewrite just the number for G. And I'm putting units with it, which you should do. If the units confuse you, so you don't have to write the units for this part, but make sure you write them at the end. 5,500. I'm going to grab my calculator real quick. All right, here I come. 5,500 times 9.8 equals 53,900. Okay, and it's a force. So even though it's a force of weight, in physics, the unit is still newtons. Okay, a force of weight in physics is newtons. All right, and we can put a box around that answer. Right, last question. Well, it says, in what direction does this force vector act on the elevator? So if the elevator is accelerating up, it's being pulled up, so that means that the direction is up. Okay? Number 26. Just as the last passenger steps out of the elevator and the 13th floor, a malfunction occurs and it begins dropping toward the ground in free fall, ignoring friction, okay, and the fact that elevators are designed to avoid this type of accident. What is the downward acceleration? How fast is it moving after 2.5 seconds? So the downward acceleration for 26, okay, it is in free fall. The downward acceleration of anything in free fall is equal to g. So acceleration equals g, small g, okay, acceleration of everything on the earth, 9.8 meters per second squared. So the acceleration is equal to g, 9.8 meters per second squared. The next question is asked, how fast is it moving? So I'm going to erase 23a so we have room. All right, 26, let's put the rest of 26. First we need to write our formula. Velocity equals g, okay, that's what asks how fast it's accelerating, times the change in time. All right, so g equals 9.8 meters per second squared. Change in time equals 2.5 seconds. I'm going to erase some more here. All right, so let's put the numbers in. Velocity equals, instead of g, we're going to write 9.8. And instead of delta t, we're going to write the number, 2.5 seconds. And then we're going to just multiply 9.8 times 2.5, 9.8 times 2.5, and we're going to get 24.5. Okay, it's asking for velocity. We know our velocity units are meters per second. I'm going to put a box around that. And I have one more question to ask you because you need to know this, okay? This is a little extension, so pay attention. The book does not ask you how far did it fall after 2.5 seconds, but we're going to answer that with a new formula. I'm going to write the question, how far did it fall? Okay, in 2.5 seconds. Okay, we're going to put a formula here. The distance that it falls is equal to 1/2 times the acceleration of gravity. So I'm just going to put g because that's the acceleration we're using, times the time squared. All right, and you'll find that in your reading. You'll see a graph with that. So let's put this down. G equals 9.8 meters per second squared. Change in time is still 2.5 seconds. All right, so we wrote our formula. We wrote our variables. Okay, now we're going to substitute. D equals 1/2. We already have a number there. G, we need a number there, so we put 9.8 meters per second squared. Delta T, we have to put the number there exactly like it is in the equation. It's in parentheses, so we need to put it in parentheses. 2.5 seconds. Exactly as it is in the formula, it's also squared. All right, so notice delta T equals 2.5. So the number goes in the parentheses, just like delta T, and then it's squared. So we put a square outside it. So what are we going to do with that? Okay, real easy. Okay, we're going to start with squaring because squaring is what you learn in math. That's what you do first. Okay, you do your exponents first. So 2.5 times 2.5, we just squared it by multiplying it by itself, times 9.8, okay? Then we're going to multiply by 1/2. We can multiply by 0.5, or in my case, I'm going to divide by 2. It's the same thing. So 2.5 times 2.5 means it's squared, times 9.8, it equals, and then divide by 2. And give that a try on your calculator. Make sure you get the same answer as I do. 30.6 meters. Okay, it's asking for meters. 30.6 meters. All right, and I'm going to change that. I'm going to round up to 31 because everything else is in 2 digits. So I'm going to be consistent since I'm multiplying. 31 meters. All right. So your first question that you're going to do on your own will be write the formulas. So you had 4 formulas. Make sure you write those down again. And you'll be doing the exact same type of problem. You'll be solving for distance, for velocity, and for force.